Right folks, we're going to put some time into this. I don't think we're going to complete it today because it's so complicated to set up. And that's a Grandstand Gemini I bought on eBay. One of the most expensive sets there was, like £159 type of money. I think you could get them for £129. Telecom's TC9000 uses the same chassis, was a bit less money. Telecom's TC9000 comes with a selective call option, but they never did a selective call unit, so that was a pretty pointless feature. And then there's also the version which doesn't have the selective call option. There was early and late versions, but it's still the same chassis. This chassis was used. There was a Wagner version, because when Grandstand went bust, Wagner bought what was left. So there's a Wagner version, spelt with a W. So these were made by Suruga in Japan, and you'll see them obviously as Wagner and Grandstand, but there is also the Atron, whatever you want to pronounce it. But beware, there's some Atron European sets which are half watt for the Dutch market. They're PTT mark approved, so they're not approved here, and they're going to not work very well at all. So there we have the Atron, which is available like the Grandstand base. It's the same as the mobile. I say some of those can be 22 channel half a watt. If you don't watch out, make sure it says 2781 on it and not PTT mark. Now the back of these is interesting because it's DIN sockets for the I've no problem with DIN sockets at all, and just because the Japanese decided to go down the phono route to please the Americans, there we go. I think most of my hi-fi is DIN. So this has the advantage that you can put the DIN plug in one way for external speaker, and it's with the internal speaker. You can put it in the other way, and it switches out the internal speaker. And then you've got public address, and on the base station you've got a tape recorder socket. But like the tape recorder socket on the Fidelity 3000, for some bizarre reason it only records the incoming side. I mean, it would only have cost an extra capacitor to make it record the outgoing side as well. So there we are. So I bought this on eBay, and it's kind of working. I can't remember whether it was spares or repairs. But one of the things he mentioned in the advert is that somebody's changed the socket. It should be 5-pin DIN. There's nothing worse than somebody changing the sockets or somebody changing the wiring. There isn't a standard, and some people seem to think Cybernet standard. Where's Cybernet now? Making solar panels. No radios whatsoever for 20-something years, since Kyocera bought them and closed them down and turned it into a solar panel factory. So there we go. There's an overview. These use a phase lock loop chip, which was obsolete when these were made. Does this remind us of the Grandstand? I've got Grandstand on the brain. The Binatone Long Ranger series of walkie-talkies, which used the MSM whatever it is synthesizer, which was obsolete when these were made. These should be black screws, so you know it's being messed with. It was shown on eBay transmitting, and the vendor also said there was no transmitted audio. That could be because of the modification. Putting that socket in has gone wrong, or it could be a fault. That shouldn't be a problem. The chassis you'll see in these beggars belief, because I seem to think it's the opposite way round to usual, so we'll be taking both the lids off. So that's already wasted quite a lot of time, and we haven't started opening it up yet. I have the circuit diagram, I have our notes. They're very complicated to set up, and they're very unreliable. If something goes wrong in the IF and VCO phase lock loop can, well, you've got a lot of time with a hairdryer getting the wax out. It's a big problem. So that's why most Grandstand base stations failed to live beyond about 5 years. Double-sided printed circuit boards with relying on component leads to go from one side of the board to the other, making it, for them hoping they're going to be soldered both sides properly, is the biggest bugbear of these. The other short-lived sets which work well when they work, which we won't touch with a barge pole, which is the Shogun, and some of those others like the DNTs. So I'll put the soldering iron on. I haven't done that yet. So when we take this lid off, I think you'll find it's the component side. It is. Well, that's one thing I got right. 1, 2, 3. Perhaps there is only 3 wires go to the socket. I may be wrong. Have a very quick look at the circuit. It's the redrawn circuit. That's the Grandstand base station, but it's the same, apart from the clock and the power supply. And what we got here. Okay. Yes, there's only 3 wires go because it's relay operated. There are only 3 wires, so at least we've got the wiring here. It's 1, 2 and 3, which is like your mono connections for a 5-pin DIN, leaving the stereo right hand channel as it would be with the stereo 4 and 5 with nothing there. We've got a Grandstand original mic. We'll get this rewired and we'll be running with that. I might make up a standard replacement mic so we can compare. So it uses this UPC 2812C, UPD 2812C, which is a NEC Nippon Electric Company phase lock loop chip, which was obsolete when these were made. And because it's not a UK specific phase lock loop chip, it's a general purpose one, it has mixer crystals to make it do the right channels on transmit and receive, and thereby there you've got another problem. So I don't know whether I told you, a lady came around when I worked at Nottingham Radio. A lady came around and she was from somebody called National Executive Car Phones. I'm going back to the 90s when car phones were something you had fitted, and mobile ones, transportable ones, were thousands of pounds and were the size of 2 bricks. Anyway, she says, they're our own make of car phone. Look, they say NEC on them. What, National Executive Car Phones? I says, he doesn't mean, NEC doesn't mean National Executive Car Phones, it means Nippon Electric Company. If somebody has told you that in the office, then you need to leave this company. What a load of BS. You couldn't make it up, could you? We're saying it's National Exhibition Centre next. 29 September 2025. We've got that Uniden 300, the first one to finish off. We've got a audio line, one of those to do. We've got the G-Col GT858, which you haven't seen part 1 of because I haven't even concluded the part 1, and I'm still pushing this through. And the reason I'm pushing this through is because nobody has seen a Grandstand Gemini, and I thought even if we can get a part 1 in to this, it might appeal to somebody. I like to have unusual sets as long as they're UK. We'll do the serial number later. So I'm going to put its XE-Bay. And the next point of discussion is that it does so many watts output and shows a picture of a meter. And I'm going to show you this. He's got some frequency counter, and you know, I'm not bothered about it doesn't have 8 digits, but you wouldn't be able to. I've done the discussion on 8 digits frequency counters and why. But he's got this SWR 508, the CQV SWR 508, which I noticed on the hobby market, you know, you do see these. But here's the problem. He's showing it doing 3.6 watts, which is probably right. And we've got an SWR of 1 to 1.16. But I don't know that, it doesn't say in the blurb, we don't know if this is into a dummy load or into an antenna, because it can make such a difference. You can end up into an antenna. Suppose you've got a 4-watt radio, and it says it's 5 watts into an antenna, which it can't be. And on converse, it could say it's 2 watts into an antenna. So you always have to have it on a dummy load. And if you're selling something on eBay, say it's into a dummy load, or show it is into a dummy load. It's the only way it can be done. So yeah, I mean, fair enough. It shows it to be low on frequency. In fact, it's on the border of being illegally low, but it doesn't matter because we can pull all that up. But that's we ought to buy one of these hobby meters just to see what the calibration's like against the well, the industry standard is the I've already forgotten what the industry standard is, of course. It's the American bird through line. So our Marconi test set is exactly the same as what that would read. But I'll be interested to see what that is. I'm not saying they're being disingenuous, it's just the way it's set up, and I just think it's better for everybody if they say, hey, this is into a dummy load. You see YouTube videos, oh, I've got my radio's doing 12 watts and it's into an aerial. Yeah, right, okay. Right, well, we're going to plug it in, and this is, we'll probably short this out because I can't do any tests until we've rewired it. We've got plenty of, I will have got 5-pin DINs in stock. We've got plenty of scrap AM sets which have got 5-pin DINs on, which we can recover one from. And hey, I can save 28 pence that way. But you know what, this doesn't look like it's being messed with. And here's this great big VCO can. To be honest, we might not need to take the bottom off. I can see dry joints from here. Anyway, we're going to go through it as it is. But one thing I will do straight away is check that these screws are tight. It does say Suruga on the board there. When we come to plugging into, we might have got an adapter lead. We might not have got. We should have got adapter leads, but you know how it is. Won't be able to find them if we had. Just look at capacitors. It's probably not worked enough hours to have any duff capacitors, but time can of course kill these as well. And we've got an unusual audio IC on these. It's another NEC device, I think it is. Or is it Hitachi C1181H? The relay's down there, and there's one of these oversized TO92K transistors, which is a regulator transistor. I've had that fail before now. So some of these are actually labelled, some of these presets, and some of them are not necessarily correctly labelled. Do these have low power? Yes, they do. Good. Right, well, we're going to switch it on. I'll just get it powered up. So, you know, these are capable of very good results, and I'm going to warn you another thing. You know what? If you are talking to somebody or hear somebody on one of these and they're over deviating, these are so selective that it'll be like listening to a Norman Collier stand-up comedian routine. Is how it will sound. And it's not the set that's faulty, it's the people doing the over deviation. So what sounds great on a Fidelity 1000 will not sound great on one of these. This stupid clarifier knob is Delta Tune. Obviously there will be for different markets there'd be AM FM ones and BSSB ones. We'll make sure that's at full, we'll make sure that's at minimum, and let's take it from there. We're going to power it up. I'll start at 12 volts and we're lit up at 12 volts. I've got 367 milliamps. Noise blank is quite a complex circuit, it genuinely is. If I remember rightly, it's looking for clicks and that, like ignition impulse noise, and it will insert a blank. So if it hears click, it will cut the receiver for that millisecond so you don't hear the click, but of course you don't hear anything. So it's not just a capacitor, it's a pile of transistors and things. It's quite complex. And it's one of the few sets which has a linked-in squelch. So we need to put this into transmit. So if we're really clever, we can short this out, and it's going to be what wire? I've got the instruction book here because I had the sense in 1981 to photocopy all the instruction books which went through our hands at the time. So our transmit is pin 2. So, well, you can't really go wrong, there's only 3 wires. So it'd be pin 2 to pin 3. Oh, of course, but of course they've altered the... yeah, of course they've put a 4-pin one on, haven't they? Well, it's going to be ground, which is there, to whichever makes it go click. That one. That's interesting, it didn't go back to receive. We've got a dirty relay. Oh, I've got his test set making the noise, not the radio. Okay, so switch picture in picture on, and let's have a look at what we have got. So we're on channel 20, I'll just turn the volume down. Into transmit. So it's 2.3 watts. .3 watts on channel 20. Let's go to channel 40. It's 2.25. And on channel 1, it's 2.4. On low power, let's go back to channel 20. On low power, we've got 150 milliwatts. And the transmit current is 994 milliamps, which is a lot for that output. We can't do the deviation. We will be doing VCO to some extent, and we're going to look at the frequency. Let's put the frequency counter up. Oh my goodness. This frequency counter is a bit fast as well. 2779800. Am I sure that we're on channel 20, aren't we? I'm just going to waggle this channel selection in case it's got dodgy contacts. That's like doing channel 19 on channel. That's better. Yeah, it's got dirty contacts. It wants a bit of use. That's much better. 79108. Oh. We'll amend that. When we key it up, let's see what the meter says. It says 4 on the front, which is full scale deflection. So we'll put full scale deflection down there. Doesn't have a meter lamp. The switches work. We don't know about the sockets. We don't know about the PA. The speaker works. And let's put in the frequency. of the signal generator, 2779. And it's 108. So being absolutely fair, the signal data is 0.3 and I can actually hear that. So go over to the SINAD meter. We're going to have to connect the SINAD meter to the radio. So I think it's this one. We don't need an earth because it's picking it up through the instruments. It actually sounds off frequency, which figures because... Let's play with the clarifier. Oh, yeah, can you see? Worse. I'll tell you what, center position is... I'm going to be fair, and I'm going to set the clarifier for the best receive, because the receiver and transmitter are separate in the way the frequencies are generated, as I've said, because these are mixer crystal. It's not good, but it does work. So we've got, man, it's better than some sets. 1.34. .15, and if it does 20, it just does at 10. Squelch. Could do with a spray. It's a bit noisy. Let's put the squelch to full. See when it comes in. I'll show you the attenuator. So yeah, I mean it's a trade working set. Yep, the squelch does come in, and it's at the moment it's at 30 millivolts for full, which is a bit tight, and for minimum, set that to standby. I think we've got a problem with the squelch control, folks. I can't get a reading because it's dirty. I'll tell you what, let's give it a spray. At least the full size controls on this. Give it a waggle round. Let's see whether we can get it to work now. No. It's like 20 microvolts. Yeah, must be miles out. For 100 microvolts, let's see what we've got, and it's reading S3. Check our RF gains at full. It's S3. Right, so here we go. We'll make a start on this before I go and do something else. There's a picture which shows underneath this VCO can, which we may well have to take off. So it does work. There's a possibility we're going to get away with this. I spent hours working this out. Right, we'll go into transmit. Show you the right meter. And we start with T2. And that was absolutely spot on as it was. T1. Absolutely spot on as it was. Absolutely spot on as it was. Just about 3 watts. I think that is it. Transmit meter is there. I'll just prove that to myself. Especially if I can find the right trimming tool. Where have I dropped that then? Yep, it is. Yep, so there we go. I'll look at some of these airspace coils, but I think 3 watts is where we are with this. Change scales. Very important placement of these. By the time this is cooled down, it's probably going to be about 3.2. See whether that makes any difference. Right, let's go to low power. See whether it's adjustable on this radio. That is squelch, if I am not mistaken. VR2 under that wiring has not come through on my photocopy. I'll take it out of transmit and we'll just look at the circuit diagram because there may not be low power on it. I can't quickly see that it's adjustable. Right, so what we're going to do is we'll put it on frequency. Let's go to the frequency counter. 27,79115. It's not very far out, and the frequency is this one. You've got that hole, that hole, that hole, that hole with two in a one can, and it is the right hand yellow one which is the transmit frequency. I've got it just slightly high, which is absolutely ideal. So that's good. Twenty-seven, 7, 9, 1, 2, 6. So I think we'd better find out what it's receiving on next. So we're going to set the signal generator up for the proper frequency, 79125. Set the clarifier to center position. Take the tone off, and now we'll plug in the other signal generator. And we'll set this to 10.695. So to be quite clear, we've got 27,79125 going in. Let's turn the volume up. So I've turned the tone off, I'll put it on. And now we've got the second signal generator here on 10.695. So we're going to wave this in the general direction. And let's see, it's somewhere down here, the receive frequency. Let's just look at my notes. L10. It's the relay. It's that one. It was absolutely spot on. How about that? I can't believe it, Mr. Tango. So it's pretty close on transmit. So close that it didn't need touching, and spot on receive. So the fact that it's receiving badly must be for other reasons. So we'll start with L14. I'll show you the SINAD meter. That sounds IFy. Let's just change the level. I'm going to see the S meter as well, so I'm going to just pop that up. I wonder if that's squelch or whether it's S meter. That's squelch. So VR2 must be S meter. Right, that's estimated to full sensitivity. Look at the SINAD meter, the oscilloscope. I ought to do the detector, to be honest. I'll just do this, then we'll go back and do the detector. To be honest, that looks like the detector. I think that's what it is. It is L14. We've started with the detector, so there we go. So I got there eventually. So LT13. I'll tell you what confused me. That's L14. That's T14. So T14's in the IF. I'll probably have to go through this several times. T13. T12. And then we drop the signal generator and do (11). That's the one that's out. Miles out. Don't touch that, it's VCO. That's substantially out. I'm going to go through these again. That's T8. What does T8 do? Because we haven't touched that, and we're not going to unless we know what it does. Five, 4, 6, 7. 8. Eight and 9 could be solely in the noise blanker. all this is noise blanker. I don't know whether we can touch anything on there, but I'll tell you what, I'm going to activate it. I'm not going to make it any worse. I'm going to be very, very careful not to alter this in any way. Yeah, that's correct position, and I think 9 is also noise blanker. They are okay, so switch noise blanker back off. I'll just go back on these IFs. The biggest signal on. Looking back at the notes, T12, definitely correct. T30, I've just dropped my signal slightly. 13. And 14. Drop my signal slightly. Just going to go back again. Every time the tuning's getting sharper. I'm happy about that. Let's check L14 now with the oscilloscope. 100 microvolts in. That's okay. Just need to find out what L13 does. Let's turn the volume down a fraction. .24 injection into the receiver, so that is relevant. Back to the SINAD meter, especially if I press the right camera. There's its peak. So I don't think there's anything we've missed. We know that's VCO. We're not touching that. These are all to set up the synthesizer. We're not touching any of these other than the one there, which is the transmit frequency, the one there that's the receive frequency. So no reason to suspect these are wrong, or it wouldn't work on all 40 channels. And then you would have to take the lid off and start poking around. What fun. What I'm not getting though is much of a display. We've got quite a signal going in, and we just don't get the fairy lights. So S9 gives me S5, and we're on full chats as far as that goes. And it's not stupidly out, don't get me wrong, but it's showing S9 as 140 microvolts, so it's slightly what you'd call a lazy meter. But there you are. That may be how it is. I'll look at the specification in a moment. What I want to do is look at the sensitivity. Now I've got that as meticulous as I can. Well, you know what? We've now got 0.92 microvolts. And it sounds right. Let's see if the clarifier makes any difference. You see, it does. Why isn't that central? I wonder if there's an adjustment which hasn't ended up being set for the clarifier. So when I did the initial figures, I used the clarifier, as you know, to get the best possible result, which is what that's. We'll do that again, so I'm being fair to myself. We've now got 0. Are we on the right meter? No, we're not. We've now got something like you'd expect, 0.76 microvolts. Still not the best you've ever seen. It's 1.75. It's looks like better than 10, isn't it? Yes, Mr. Tango. And 10 dB is 0.7 on the dot. Squelch. Turn squelch to full. See whether we can make this come in at 100 microvolts. The answer is we can. So that's now how I want it for maximum. And this may, between the tuning and that adjustment, we may well have got an acceptable squelch now. Still a bit noisy. It's bad to being clean. I think we've got a duff control, you know. So try cleaning it again. I think he said these are being stored in a shed. I'm having to have it higher than you'd expect. Might have to change that. I mean, that's like 30 microvolts because I've got it so high. It's funny that, because all the rest are working. Yeah, RF gain is. So we've got a lazy meter, but it's not stupidly out. Deviation, well, we're going to have to come back to this when I've done the mic socket. So there's three things to address. There's two things to address really. The squelch control needs replacing, and the microphone socket needs removing. So I'll just make a very quick start on that, and then we'll leave it for now. But at least we've got, I'm not bothered with the fact it only does 3.2 watts. I think it's about what these do. Don't think I've ever seen 4 watts out of a Grandstand bass or this mobile version. It doesn't matter. Right, so we know the brown one is transmit. This has been done nicely. They've left the ferrite bead in place. So brown is transmit. I'm just going to make a note of that. So you don't need receive. So the audio is white. It's one of the few sets where you don't have to have a mic plugged in. And of course then you've got the black one, which is the ground. You can actually see what I'm doing. We've got 3 more emergency sets to do, so those of you who hate them, there you go. We had none for ages and then loads. I just love them to pieces, the emergency sets. Oh yes. I wonder if we can get that off without any proper tools. Can we get the big pliers in? This is a recovered socket somebody's used, and it's got solder on it, and that doesn't help the nut to come off. But we will have to use that yet again, so it'll get a third life, you never know. So what we should have got a scrap illegal Midland 100M there. That can this will be really low hours, so we'll have that. I hope they haven't expanded the hole, that would be annoying. It's relatively easy to get at on this grandstand. Can't believe all the trouble they went to do that noise blanker. Not sure there's supposed to be decoupling capacitors on this or not. Yeah, there should be. I'll go and clean this up off camera. Right folks, we've got a microphone now wired to this. So I've done the DIN socket and I wired it as the circuit diagram, and oh, put that up there. So this is borrowed from a working set, so we expect it to have transmitted audio, but I've just tested it and it hasn't. Just as the vendor said, there's no transmitted audio. I've got the walkie-talkie on. 1212, nothing. Absolutely nothing. Right. So we know that the white wire is audio. So to be honest, I should just be able to put my finger on that. We had a spate of no transmitted audio recently between capacitors and chips. Every other set's had no transmitted audio. Of course, it's the part you can't get to easily, isn't it? So I'm touching that. There's nothing there. That's the transmit. So well, let's see where this wire goes. Oh yeah, all the way down there, does it? Well, just for stupidity, let's see what happens when we adjust the deviation preset. Could be as stupid as that, but it won't be. Yeah, well, deviation's in this can, isn't it? Touching that, we've also got no deviation. So you know what? We're gonna, yeah, we're not out of the woods with this, are we? We're gonna end up having that can off. I thought it was too good to be true. Let's turn the set off. So we're looking at somewhere around this area. I'll just run through this for dry joints initially, clean it up with isopropyl alcohol and come back to the video. Right, I've gone over this area in the on the VCO, and I've just done the isopropyl alcohol, and I've done another couple after that because I could see clearer. Now, the trouble is, it's going to have to dry, isn't it? But I'll tell you what, we'll switch it on. But it's still receiving, and it's transmitting audio. So we haven't had to have the VCO going off yet. Right, we'll just turn the volume down on my receiver. We'll look at the deviation meter on this test set and see if we can set it somewhere near. What I was going to do is, as part of the fault finding, I don't need to now, I was going to have to go on to public address and see whether we've got public address working. We'll make up an adapter lead for that. Alright, let's have a look. Deviation is that one. Wallow. So if that's right, that's where it should be. I'm going to check with the test set behind me. I didn't show you the right meter. Nothing like locking the door after the horse has bolted. There's the meter. We'll come back to that. I'll just plug into the test set behind me. It's a squelch control on this. It's knackered. Wallow. It looks right, but I don't think the machine's ready. So I'll tell you what we'll do. We'll turn the power off and we'll get these knobs pulled off and get this squelch control changed. But I am pleased with this because the person selling it has been quite truthful. It is a trade working set, and there you are. He said there was no transmitted audio. There wasn't. I'm sure one of the wires was wrong though on the mic, but then we don't know what he'd actually wired it for. And that was another. So the full size well, not that full size. They're not like you get on a Dansette record player. I don't know why I mentioned Dansette ones, because it would be HMV with me being an ex-HMV dealer. It's not often we have to change controls, but if it's been in a damp environment, you just don't know. I've done my best spraying it, at least the kind of construction that you can actually get into. It's 10k. Of course it's, I don't know whether to open it up and see what's wrong with it. The kind of thing Mr. Chippie would do. Let's see what we've got on this. Because, you know, you've got the same controls on this Maxon set. It would be nice if it was something near 10k, wouldn't it? This is the AM set we pinched the mic socket off. Oh, 10k! Ooh! We'll have that. And I expect illegal AM sets to be quite low hours. Well, I managed to separate them because they were shorter together, weren't they? Same length. This is a branded one. Oh, it's Alps, this is. Oh. I'm not going to clean this. It'll be interesting, that one, won't it? So it's the left two. So just clean the holes out. So I could do a little vise on here, but I've got that on the next bench. But I'll just try and. This video is going to be long, isn't it? 2 hours fixing a working Grandstand Gemini. Got another one of these on the shelf. I wanted to show this one because I only bought it recently. There we go. We're only using 2 of these. So the yellow one is the left. Yellow one the left. Ow, that was touched my finger on the one I've just unsoldered. See if we can get the blue one off. And of course I can order these, it's not like difficult, but I thought we'll try and use some 40-year-old parts to go with the 40-year-old set. I don't do this with transistors and resistors and capacitors, but stuff like this, especially when it's been recovered off something which is low hours. Which are all as easy to get to as this. So before we put the front on, we'll try it. Power on. Well, it could be dirty. It's totally different to how it was. Yeah, absolutely as you'd expect. We'll get that set up on the test meter, get a reading off it. So we need to just deal with this front. I mean, that's pretty clean. I don't think I need to bother doing anything further to that. To be honest, it clips in, so it's just somebody's just pushed it. It doesn't need gluing or anything, it just pushes in, so it should come out of its clips. Right, 2 screws. Remember to go quite lightly on putting screws in these front bezels. Wonder when this last worked properly. Who says it works properly now? Right. Is 20 there? I don't know. Let's get these back on. Where's the other one? There it is. So we want RF gain to full, clarifier to about 2 o'clock, squelch to minimum. And let's go with that deviation setup again, because that's about all we need to do. So on the test set behind me, I've got the wrong glasses on. Wow. Could just do with the tiniest fraction more. It's about 2.3 peak. I'm really being a bit over the top here. Wow. That's it. Turn that test set off. Back onto the Marconi one. See what it says on this one. Wow. It says about 2.6, but it's 2.5. So I don't know where it was before because there was no deviation, so it was nil. We're going to come back to power right at the end. So it's 2.2 to 2.5 kilohertz. I think the S meter's changed slightly because the clarifier seems to be compensating for the one of the crystals being very slightly low. I think we've got S9 on 100 microvolts. Well, I did see it once. Yeah. So we're going to put is 100 microvolts. It is on full sensitivity to do that. Put that squelch hot replaced. I mean, what were the chances of the squelch on the what did I say, 100M being the same? Yes. Replace mic socket. There was only one ferrite bead, so I've put it on the audio because you're not going to have a situation where it's going to start triggering into transmit because of RF getting back into it. I'm sure you wouldn't. So, you know, we've got decoupling capacitors which weren't on the mic socket they put on. I recovered those off the one from the Midland 100M. So now we can do the squelch. So I think I'm sure squelch full is correct. So let's go to the attenuator. It's 100 microvolts, 1, 3, 10, 30, 100, and it's coming. So that's full. And then minimum, let's set threshold on the radio. Now let's see where the squelch comes in. It's not good. Eight microvolts. Oh, I'll try and set it again, but I'm being more careful this time. It's 8 microvolts, it's awful. But we've been through the we've been through all the IFs and everything. It's better than 20 microvolts. But it needs to be under 2.5 to be successful. So we're going to be struggling getting Mr. Chippie, you know, at the 5 mile point and all that without popping the squelch down, which is disappointing. Right, let's see what the transmit power now is. So we've let it cool down, and I don't think we've come to a conclusion whether the low power is adjustable. I don't think it is. So let's have a look at the power. I'll go over to the main meter, key it up. I'm in the wrong mode. It's well beyond 3. It's 3.4. Let's do other channels. Channel 40. 3.4. Channel 1. It's actually 3.3 on that one. So low power. Oh, let's see what the current consumption now is on channel 20. It's 1.14. 1.14 amps. So we've gone up just over a watt, and it's actually what it's come out as what he advertised it as, hasn't it? Not that it makes any difference, because I say when you're selling something and you want to show it into a meter, yeah, it's a great idea, but you really need to put it into a dummy load, or it doesn't mean anything. And if he and other people do, say it is. So we're back to this low power. There isn't a preset, is there? Let's just look once and for all. Let's just to wrap this thing up. So we've got TX power. So we know that. We've got, which is the meter, of course. We've got deviation down there, which is all well and good. We've got squelch up there, and this was RX meter. So there aren't any more presets, so it hasn't got low power, which is adjustable. So we'll see what it is. And in low power, it's 180 milliwatts. 180. So there we are. Meter on transmit. It's a psychological thing. We'd always set these to read 4, even when it isn't. I've got to make sure it isn't over the top 4, if you understand that. So I'm going to key it out. Let's see if we can all see it together. I want it to just touch the 4. There. On low power, it'd be nice if it read 1. It doesn't, but there you go. So that's set. We haven't tested PA. I'm not going to at this stage, and of course I don't know whether we're going to have time to make a mic up or whether we're going to run with the Factory original or borrowed from another set. Testing 1 2, testing 1 2. So there we go. So that wasn't a 2-minute job, and this isn't going to be a 2-minute video. I'll try and find some black screws, because there are definitely black screws on these. So we ended up with good sensitivity. It just didn't sound right, and we've ended up pretty close to what you could call to be 4 watts. So if it was 3.5, it counts as 4, doesn't it? That's how averages work. I'll get some new screws out of a packet. Have we got any on the bench? I doubt it. I've put all the paperwork on top of the microphones, so that is really going to help the audio. I'll have to go and look at where the black screws are hiding. So I tell you what, let's see if we can just find 2 second-hand ones on the bench, just to stop this falling apart and sliding around. Then we'll plug the aerial into it. So. That stops it falling apart. There's our DIN socket, as it should be. And we'll disconnect the test gear, turn the test gear off, and find the aerial. Right, there we go. Turn the squelch down. 19 a Roger. Let's go to high power. 19 a Roger. There we go. So you've seen one. We was doing on the air test. Did that TX light work? Yes, it does. And I'll just show you the original mic. It looks like those. Do you remember those? Was it DM520 power mics? It's very similar to that, but that's what the original mic does look like. Right, so we're all ready for an on the air test. And apart from the squelch, that should work fine. Thanks for watching the Grandstand Gemini, made by Suruga in 1981.